I'm really pleased to introduce you to today's presenters, the brave ones that are going ahead with the first Innovation for Scale session. Thank you, guys. We're joined by Anissa, a data engineer from Pulse Lab Jakarta, by Katerina, the head of food security and nutrition analysis from the World Food Programme in Indonesia, and by George, who's the head of the data science team in the Pulse Lab Jakarta. And together with colleagues from Pulse Lab Jakarta, WFP, and FAO, Anissa, Katerina, and George have developed a really great platform, and I am 100% sure the platform has the best name in the UN. It's the Vulnerability Analysis Monitoring Platform for the Impact of Regional Events, or short VAMPIRE. So with that, I would like to hand over to Katerina from WFP to tell us a bit more about the problem that VAMPIRE set out to solve, and introduce us to what you've developed. Katerina, the floor is yours.
Thank you very much, Johanna. Good evening, good afternoon, good morning to everyone online. Thank you very much for your time. So let me tell you about VAMPIRE and how it came about. So I'd like to start with the context when VAMPIRE came about and why there was a need for such tools, so that this will hopefully help you understand the problem and the need the platform was trying to solve and address. So there were two key points related to the context. So one is related to the 2015 El Nino drought, and second, the disaster risk profile of Indonesia. So in late 2015, one of the strongest El Nino on record induced drought conditions affecting Indonesia. At that time, number of subnational governments declared emergency. There was lots of anecdotal evidence, one pointing to an extremely severe conditions, another to quite opposite, and there was an overall confusion on the basics. No one could clearly say how severe the drought is and how many people are affected and how badly. Of course, the government of Indonesia, international community in the country, and the humanitarian actors were asking these questions. But given that there was no clarity on the answers, there were rising concerns of the potential impact on the country. And this was particularly relevant for two reasons. Firstly, while Indonesia is a middle-income country and has shown economic growth in recent years, many people remain food insecure, and many areas are vulnerable to food insecurity. In addition, over 100 million Indonesians are agricultural and belong to agricultural household, hence impact of drought on their livelihoods could be detrimental. Secondly, the 2015 drought conditions resembled the last strong El Nino in late 90s, which also coincided with the financial crises in the region, and in Indonesia had very serious political implications. So because of these two reasons, there was a very strong interest to quickly understand the conditions on the ground and take necessary actions. Now, to be able to do that, we were looking for different data sets and information. Now, data was available, which is perhaps unusual in many different countries, but in Indonesia, we have lots of data. However, data was scattered, sitting in different ministries, agencies, formats, providing only a very fragmented view, and using traditional means for analysis and assessment, assessing and answering the two basic questions on how severe is the drought and how badly are people affected would perhaps take weeks, if not months. Hence, there was a need to have something to quickly stream the multiple data sets and provide a clear picture of the situation. So that was the first point related to El Nino. As I mentioned before, second important element that led to the setup of VAMPIRE was the disaster risk profile of the country. So whilst Indonesia is known for its volcanoes, earthquakes, and tsunamis, it is actually climate-related disasters that account for around 90% of all damages and losses. These are floods, droughts, landslides, and strong winds. These disasters occur regularly and seasonally. Therefore, having a continuous update and understanding of environmental conditions and their potential impact before a disaster hits is particularly relevant when we also would like to act early and prevent or mitigate the impacts. So, in short, this was the situation we were facing in Indonesia just before Vampire was set up. WFP and FAO were very lucky to have Pulse Lab Jakarta in the country, who were there to hear us out and help to set up the system that, in short, answers the questions on how severe are the environmental conditions, in this case, drought and flood, and how many people are affected. So thank you very much for the context.
Thank you, UN Innovation, for the opportunity, and thank you everyone who attended this webinar. Okay, now I want to discuss about how does Vampire use. Vampire is a platform that shows the data visualizations on map where drought and flood hit crops or populations. In general, Vampire has three main layers. There are baseline layers, climate layer, and impact layer. And the different data has been applied for each layer. The baseline provides socioeconomics data, and the climate layer provides the analyzed data which related to the drought and also flood. An impact layer provides crops and populations which affected regarding for both disaster. And I will explain for each layer for the next 3 slides. Okay, this one is the baseline layer. As we can see in the baseline layer has two type the data. First is population below national poverty line and also population density. And the data has been provided by the National Statistic Agency of Indonesia. The baseline layer basically is just general information about population distribution in Indonesia. In Vampire, if the user chooses population below national poverty line, then it will visualize the data into map, which distinguished by the color. Let's say it's like when this it will shows where the distributions of populations in particular area which are below or above poverty line. And the second is a climate layer. Climate layer contains analyzed data which has been generated in backend process. As we can see in the below, there are meteorological drought, about the drought and flood hazard, such as rainfall anomaly, precipitation index, number of days since last rainfall, and vegetation index data. And Vampire use rainfall and vegetation data by accessing US Geological Survey and NASA in the free way. For instance, when user choose the flood hazard forecast in the indicator menu in climate, it will show the area which potentially indicates flood by comparing mean during the number days to the same days in the past 100 years as a base. So when the value higher than a base, that the potentially cause a flood. And on the below of the map, you can see that the timeline that indicates when the data is available. There are a blue color kind of toggle that user can drag the toggle and visualization will change the data respectively. Or user can also choose the calendar or the timeline. And the last is impact layer. Impact layer contains the data for affected crop area and also population for both hazard. Flood impact use flood hazard forecast, as we can see on the below at the left side. There are population impact for drought, population impact for flood or crops for both. Flood impact use flood hazard forecast in climate layer combined with the crops satellite imagery that has been used to get the crops affected area. And for population index, we use the same source to get the population impact combined with the population density in the baseline layer. So basically all the layer is combinations and analyzed in the backend process to get the result in impact layers. So the policymaker will have create the policy for disaster happen for drought and also flood. Yeah, thank you.
Thank you very much, Anissa. So indeed, before we're talking about scale up, just from a user perspective, indeed Vampire might look like a simple map, but it's ingenious in how it basically allows to, on the one hand, visualize very complex analysis in a simpler format that is understandable to very high-level decision makers who only have time to look at one thing. And secondly, it's very useful in the sense that it's a processing pipeline that automates data acquisition and processing that really frees up lots of valuable human resources that can focus on more nuanced analysis and other areas, having those questions instantly answered in a system. So now in terms of the scale up or actual use of the system, Vampire has been installed in the presidential situation room in Indonesia, where it's part of a broader early warning system that is being utilized by President and his team for prioritizing and choosing location of interest where interventions might be necessary. Vampire was also contextualized for government of Sri Lanka to also serve as a tool to monitor and provide early warning for droughts. And it's currently embedded within the Ministry of Disaster Management. In WFP, in 2017, Vampire won the WFP Innovation Awards. Also jointly with PLJ and WFP, the idea of Vampire and the entire system was pitched at Accelerator Bootcamp, where over 200 investors came and looked at the system. Vampire also received funds for scale up of the system into the broader region in Asia Pacific, where we are looking at potential use of the system for other countries and also potentially different types of disasters. Also, there is a plan to make the system open source so that other could benefit from the code and make necessary iterations. So that's in terms of scale up. As it comes to the decision making and the impact, and if we can please go to the next slide now, perhaps. Thank you. Let me tell you a little bit about the impact Vampire had so far. So in Indonesia specifically, the system triggered really big underlying changes in government's business process and decision making that in fact went beyond the intended use. So in principle, the Vampire basically assists governments to base their decision making on objective evidence. And this evidence is without any political shading, any political attachment. So it's a system that gives solid objective evidence that the government can base their decision on. This might seem very simple, but in terms of disaster preparedness and food security, in a country as geographically diverse and large as Indonesia, this is particularly challenging. So the system really brought all this multiple data from multiple data sources together into one map where it provides very clear and simple solutions so that the government can easily prioritize locations for disaster preparedness or for targeting of the population. In addition to that, the platform allows to review change in disaster impact over time. Because the system stores historical cases of disaster impact as well as current and potential impacts, this is critical for understanding the fund allocation and evaluation of the impact of some government programs around disaster preparedness, to be able to see if an area that is known to have long historical record of disasters and continues to have so, this allows this area to review their program and perhaps reassess the programs and allocation. Finally, in terms of more broader process, it triggers, this relates to the cross-ministerial collaboration on data sharing for impact-based early warning. So as we know, many agencies, also UN, tends to store their ideas, data in nice silos that often prevents very constructive solution. What the system did, it triggered cross-ministerial and cross-agency data sharing that looks particularly at the impact of disasters, impact of climate information on food security and population before a disaster happens. Indeed, this is a substantial change in terms of a business process that is related to Vampire and the process it triggered. Finally, many people often ask us if Vampire can provide very operational type of information, names of household when the government should go and intervene. So the answer is that the Vampire doesn't work at this level of accuracy. It helps to point out the locations and areas where government should focus and international community should focus and investigate more and intervene. However, the level of accuracy is not at the level where we could be specifically having the names of household that need intervention. So this is perhaps all in terms of impact policy and decision making from my side. Thank you.